Welcome to the eighth lecture for Mathematics Class 11, Chapter 8, Sequences and Series. So we had started with understanding what are sequences and what are series. Then we saw how we calculate the different terms as well as the series or sum of the terms in a sequence with respect to arithmetic progression. And we also then saw how the similar kind of examples can be solved when you have a geometric progression. Okay, so now, first, just like a quick recap of, we are still continuing with things that are, with respect to geometric progression. So your GP or geometric progression can will be if A1, A2, A3, AN. This sequence will be a geometric progression if your A2 by A1 is a common ratio R. Okay, and this common ratio R is repeated for all the successive between all the successive terms. So in a way, then the GP then becomes A, where your A1 is equals to A. The first term is A, so A. Then the next term will be A multiplied by the common ratio AR, and then again multiply R with the previous term. So that would be AR squared, and then you have AR cube, and then all the way up to A R raised to n minus 1. Okay, so this is our geometric progression. And we also saw that if you have, the sum of the terms of all the sum of all the terms that are there in the geometric progression, okay, it can be called as geometric series. Okay, so geometric series Sn can be written as A R raised to n minus 1 upon R minus 1 if your R is greater than 1. Okay, or else your Sn is going to be equal to A 1 minus R raised to n upon 1 minus R if your R is less than 1. Okay, and also we have something called infinite geometric series. Okay, so these are for when you have finite GP. Okay, so finite GP that is up to n terms. Okay, but for infinite geometric series where there is no limit to the number of terms that are included in the geometric progression, your Sn, okay, the sum of all those terms can be written as A upon R minus 1 if R is greater than 1, or Sn is equals to A 1 minus R if R is less than 1. Okay, so this is all about the geometric progression. Now we will go and we will try to see what do you mean by geometric mean. Okay, just wait a moment. I have some water. Okay, so we will be doing geometric mean now. Okay, so geometric mean. Okay, so when you say mean, so usually it depends, if you see arithmetic mean, so usually it is the, kind of the average of all the terms that are there. Okay, so average is is the sum of all the terms. Okay, sum of all the terms in suppose an event or sum of terms in the sequence, and you divide it by the total number of the objects or terms or events. Okay, so that is usually or what you understand by mean. Now, what is geometric mean? So this actually represents the central tendency for a given set of, say, terms or objects or events. Okay. So the geometric mean, okay, so the value of geometric mean, it will represent, where the, central point of a certain set of, say, terms, objects, or events lies. Okay. So usually how we get the geometric mean, it is found as the nth root of the product of given set of, sorry, given set of found slash objects slash events. Okay, so if you we will do in detail the differences between your arithmetic and geometric mean. But normally your mean is when we calculate this normal mean, you usually sum all the terms that are present, and then you divide it by the n, that is the number of terms. But in geometric mean, you can see that it is actually the nth root of the product of all the values that are given to you. Okay. So n number of values are given. So whatever your n is, so the geometric mean will be n the root of the product of all the values of all the terms that are there in the sequence or the progression. Okay. So let's just define the formula. Okay. So if A1, A2, A3, all the way up to AN, okay, is the part of term. Now we'll just write GM. Okay, GM is for geometric mean. GM, GM of the terms is given by GM is supposed to do part O into getting walking n and the n root. Okay, or you can write it in terms of A1 multiplied by A2 multiplied by A3 multiplied by all the way up to multiplied by AN 1 upon 10. Okay, so this is your geometric mean formula. So you can see over here, so this is the main thing. Okay, so you find the product of all the terms that are there in the sequence itself, in the progression, and you take the nth root of that product. Right. So it's understandable, and what it does is it will actually give you where the kind of the central sort of where is the center of the data that is lying. Okay. Or where is the data actually, you can imagine it to be centered about. Okay. So this is the geometric mean. So there are a few other things with respect to geometric mean. So we will just see some characteristics. So suppose you have two positive numbers, okay, A and B. So if there are only two numbers and you have to find the GM of these two, okay, so the GM would be root of square root of AB. Okay, because you have only over here your n is equals to 2. Okay, only two numbers we are taking. Now, for example, okay, for example, okay, your A is say 2, okay, and your B is 8. So, your GM, okay, so the geometric mean would be 2 into 8, okay, so that is square root of 16, and that is 4. Now, you will notice that this, the numbers, okay, so the numbers over here say 2, 4, and 8. Okay, so 4 is the geometric mean. So this is where your central, kind of the tendency of the, numbers lie. You will see that this itself forms a GP. Okay, with your R is equals to 2. Okay, 4 by 2 for 2, and your A becomes 2. Okay, so that is why this actually forms a GP. So this in terms mean that no matter what your, kind of, so we can state that given any two positive numbers A and B, okay, we can insert as many numbers, or like that, terms, okay, as many terms as possible between them to form the resultant GP. Okay. So by this, what we mean is that, between your A and B, okay, whatever your A and B is, there are a certain number of terms that you can actually put in between them. Okay, because we are considering the two. So whenever we take a geometric mean, okay, so there will be some, central part, or central, what is the central value of the sequence, according to which you can, put a lot of other terms in between these two terms. Okay, so for example, if you want to, kind of prove how we can do that, so let G1, G2, all the way up to Gn be n number, of terms between positive numbers A and B. Okay, so what will be the GP? Okay, such that we have, or we get GP as your starting with A, going up to G1, G2, G3, all the way up to Gn, and the last term B. Okay, now you can see that we are already considering n number of terms in between A and B. Okay, so the total number of terms that we have in this GP is, okay, so total number of terms in this GP is given as n plus 2. Okay, so n numbers of the terms in between, and plus 1, that is A, and plus 2, that is B. So therefore, your B is going to be your B is which term? Okay, so suppose let's see your, this is, all with respect to your Now, how we write normal GP as, or any sequence as A1, A2, A3, okay, all the way up to AN. Okay, so your AN, actually B becomes your AN plus 2. Okay, so, okay, so this is what we have. So now, how do we find B? Okay, so suppose we have our A as the first term over here. So as per your, normal general formula that we use, okay, n minus 1. Okay, so this is our general formula. So this in turn will give you B is equals to your A remains the same, and your R is going to be n minus 1. So over here, your n, as you can see, is n plus 2. So this will be n plus 2 minus 1. So eventually, that becomes A R n plus 1. Okay, now if you have this and you want to find the common ratio so that you can find the different terms, okay, that we are trying to put in between the two positive terms. So your R is going to be, okay, B by A raised to 1 upon n plus 1. Okay, 1 upon, because we want to shift, we want to find the root of it. Okay, so then you can get your G1. Okay, in terms of what, G1 is your second term. Okay, this is the second term. So that means your N is equals to 2. Okay, so this will be actually A R. Okay, your first term still remains A, and your G1 is your second term. So it is so that is A R. So this will be A multiplied by your R. So this will be by A. Okay, 1 by, okay, n plus 1 root. And then you can have what? Your G2 will be A R squared, and that will be A. So you have B minus A. Oh, sorry, B upon A by your 2 into 1 by n plus 1. So this is 2 by n plus 1. Okay. And then you can have your G3 is equals to AR cube over here. Why are we writing? We are saying G3, but we are considering it R cube because actually this is your A fourth term. Okay, so this is the fourth term of your geometric progression. So this is A, and then your B by A, 3 n plus 1. Okay, all the way. If you want to find your Gn is A R n. Okay, so this is actually your A n plus 1, and this will be A B by A m upon n plus 1. Okay, so this is how we can find all the numbers that can actually fit between the two positive numbers. Okay, and we can get the entire geometric progression using that. So let's do a quick example where we can see. Okay, so suppose, for example, find three numbers between 1 and 256, so that the resulting sequence is a GP. Okay, move of GP. Okay. So over here, the first term is 1. Okay, so A is equals to 1 and B is equals to 256. And we have to find three numbers. So G1, G2, G3, okay, is how much? So first what we can do is, so the GP that we have to find is actually 1, G1, G2, G2, G3, and 256. Okay, so this is the one that we have to find. So what is your R we had seen? Okay, so where R will be B by A, 1 upon N plus 1. Okay, so or we can just write, get this is your 256 is actually your first, second, third, fourth, fifth. So your A5 is 256. Then how do you find A5? That is A R raised to N minus 1. Okay, so N minus 1 over here. So this will be A4. Sorry, R raised to 4. Okay, so therefore, over A is 1. So we can write R4 is equals to 256. Okay, and this would be what? This would be your R. So 256 R is equals to, you know, 4 root of 256. That actually gives you plus and minus 4. Okay, so we are only taking real roots. So using the real roots, we have if or when. Okay, we can explain. So when R is equals to 4, what will be a geometric progression? Your GP is then 1. 1 into 4 is 4. Okay, so 4 into 4 is 16. 16 into 4 is 64. And as you can see that if you multiply 64 with 4, you do get 256. And when your R is equals to minus 4, your GP then becomes, first you will have 1, then you have multiplied by minus 4, and minus 4 multiplied by minus 4 is plus 16. So plus 16 multiplied by minus 4 is minus 64, and minus 64 multiplied by 4 will be the positive 256. Okay, so this is how you can find when you have, two different, uh, the end points of the geometric progression, and if you're given how many numbers you have to write in between. Okay, so if suppose you increase it or you decrease that, you will have to find with respect to that, with as per whatever R you can get. Okay, so let's do a few examples of where we have to find geometric mean. Okay, so for the question we find geometric mean of 2, 6, 9, 5, 12. Okay, now we know that GM is given as A1 into A2 into A3 not all the way into AN on 1 by N. Okay, so similarly, we can write this as over GM with respect to R, given set of numbers is 2 into 6 into 9 into 5 into 12, 1 upon 5. Okay, so over here you can actually see that, over here we have a finite set of, terms. Okay, and there is kind of, not any, particular order that we are, following over here. Okay. So let's just take, this is just like a random set of, data that is given to us. So now the GM would be, if you multiply all of these numbers, you actually get it as 6480. Okay, 1 upon 5. How this can be written as, this will come up to as 5 point, let me just check once. No. 785. Okay, so your geometric mean for 2, 6, 9, 5, 12 is 5.79. Okay, if you round it off. So in a way, like if you, arrange that, say, like 2, 5, 6, 9, 12. So your mean somewhere, falls in between 5 and 6. Okay, so the mean value, the geometric mean value. Okay, so this is what is happening over here. Let's take the next example. Find the geometric mean of 3, 7, 21, 15. Okay, so a set of numbers is given to you. We have to find our geometric mean. Okay, so we can see our n is equals to 4. Okay, and so your GM is then going to be 3 into 7 into 21 into 15, 1 by 4. Okay, so this will be 1, 2, 2 into 7 into 21 into 15 into 4th root of. Okay, so it's going to give you 9.018. Okay, so therefore the geometric mean of the given data is 9.02. Okay, rounding it off. So again, if you see, if you arrange it in like, 3, 7, 15, and 21, your geometric mean is going to lie between 7 and 15. Okay, so in the previous one that we saw, it is not exactly coming at 6, which looks like the, center of, or which can be placed in the center of the, set of terms that we have. Okay, but it is falling close to the, the mid number that is existing over here. Okay. And over here, you can see that there are, 4 numbers. So between the second and the third number, this is where your geometric mean is line. Now let's take another round. We asked to find the geometric mean of 11, 17, 28, 65, and 14. Okay. So over here we can see that our m is equals to 5. Okay. There are 5 5 terms that are there over here. So now if we want to find our geometric mean, so geometric mean is going to be equal to 11 into 17 into 28 into 65 into 14 and This will be 1 upon 5. Okay, so your geometric mean, this calculation will be 2. You have 11 multiplied by 1,000. So, yes, 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 this will be root of 1. This actually comes out to be 21.657. So this can round it out, be around up to 21.66. Okay, so this is your GM, geometric mean. So over here, if you consider, you write these in the, kind of the ascending order of 5. Okay, so the central, central point or the central tendency of these set of terms is going to be between 17 and 28. Okay, so this is how you find it. Now, for if you have, the arithmetic mean, okay, suppose you take the arithmetic mean. So usually it usually, comes right at the, middle of the, the set of terms that we have. But for geometric mean, you can see that it can, go somewhere other, and it depends on the terms that are being also used. So let's take another question just for a moment. So the question is that the sum of two numbers is 6 times their GM. Okay. So that the ratio of the numbers are 10 times 3 plus 4 root 2 ratio 2 minus 2 root 2. Okay. So the solution would start with assume x, sorry, assuming x and y as the numbers. Okay. And so to find, we are saying that their geometric mean would then be, since there are only two numbers, will be square root of xy. Okay. And we are given that the sum of these two numbers is 6 times the geometric mean. Okay. So let's consider this as your first statement. Now we'll try to remove the square root sign. So squaring 1 on both sides, we get x plus y the whole square equals to 6 root of x y the whole square. So this actually gives you x plus y square equals to 36. Sorry, that will move all these now. So this will be x y. Okay. Now we know that x minus y the whole square would actually be x plus y the whole square minus 4xy. Okay, y minus 4xy, because when you have x minus y the whole square, the expansion of this is x squared minus 2xy plus y squared. And when you have x plus y the whole square, it is x squared plus 2xy plus y squared. Okay, so if uh, actually put over here, you write minus, or you actually put minus plus 4xy minus 4xy, okay, in the upper expansion part. So what happens is you can actually put this over here. So this can actually become x squared plus 2xy plus y squared and minus 4xy. So you can actually convert your x squared plus 2xy plus y squared into your x plus y squared. So that is what we are doing over here. Okay. So therefore, you can write x minus y the whole square. Okay, now over here we've already got x plus y the whole square is 36xy. You can write this directly for 36xy minus 4xy. So this is going to give you x minus y the whole square is 32xy. So now again, if you take the root, so that is, we have x minus y, okay, taking root, on both sides. You have root of 32 x y. This you can write as x minus y is equals to, so if you write this as 16 into 2, so 16 root of 16 will become 4, so 4 root 2 root of x y. Okay, so let this be your second statement. So now we have something with x plus y. Okay, so the 1, and we have x minus y. So if we then add, okay, adding 1 and 2, okay, what do we get then? So you will, if you add your y goes off, okay, so y is removed from the solution, and you have 2x is equals to 6 plus 4 dot 2, okay, and x, y. You take the root of xy common, and then you can write the the numbers in the terms. So x then becomes 3 plus 2 root 2 root of x, y. Okay, so now we have the value for x. Now we will just add a few more slides. Okay, so in the previous part, we had got the value for x. So now we will substitute the value of x in equation say 2. So we will get the y. Okay, so substituting value for x in 2. Okay, so our 2 was x minus y equals to 4 root 2 and root of xy. So this you can just then put, so you have 3 plus 2 root 2 root of xy. Okay, oh, sorry, we put it in the 1, okay, equation 1. Equation 1, so you have plus y is equals to 6 root of xy. Okay, So now your y then becomes, okay, you take the entire left hand, the terms in the left hand side to the right hand side. You will get this as 6 minus 3 minus 2 root 2. Okay, and in common you have root of xy. So this then becomes 3 minus 2 root 2 root of xy. Okay, so now we got the value for x as well as value for y, and we were asked that the numbers, the ratio of the numbers. Okay, we had to find. So if you take the ratio of, say, x and y is, so x by y. So our value for x was, okay, this was our value for x. So that is 3 plus 2 root 2. 3 plus 2 root 2 and in brackets root x y, and y is 3 minus 2 root 2 in brackets x y. Okay, so these two get cancelled and what you are remaining with is 3 plus 2 root 2 upon 3 minus 2 root 2. Okay, so in the question, this was what we were asked. Okay, so we can then write x by y. Okay, then row. Okay, so this was easy. Now let's do a few words on for geometric mean, find the geometric mean of 6 and 24. Okay, so over here we are only getting 2 for n is equals to 2. Okay, and we will find the square root of the product of these two. So GM is going to be square root of 6 into 24. So that is actually 4 to 144. And this is actually going to be 12. Okay. So therefore, geometric mean of 6 and 24 is 12. Okay. So over here, you can see that this actually, kind of falls in between. So you have 6, comma 12, comma 24. So this is why your central the central tendency of the central tendency of the set of numbers is going to fall. Okay, let's take another example. So we have to find the geometric mean of, and this is a multiple example. This also actually becomes a GPU, 6, 12, and 24. You will see that the common ratio over here is going to be 2. Okay. So the next question that we was trying to do is find the geometric mean of 11, 22, 33. Okay. So over here our n is equals to 3. So therefore GM, the geometric mean, is going to be cube root of 11 into 22 into 33. Okay. So this is going to be 796 cube. Okay, and this is actually going to be somewhere around 19.99. Okay, so this is your GM for your 11, 22, and 33. Over here also, if you take, you see the, 22, 33. Okay, so over here, your GM actually lies between 11 and 20. So it's not exactly right in the middle. Okay, so the geometric mean you can see it is a bit variable. Okay, let's do a few more examples with respect to finding in between terms. Okay, so suppose we have the wait a moment. The two and one by one, two and one more are 2 and 256 of GP. Find the in between in between terms. Okay, find the in between terms. So let's first find the R. Okay, so how do we find the R? You can go the where you don't have your N. Okay, so over here we do not have the N very easily to find. So what we can do is, you know, suppose you have 2, okay, A is equals to 2 and your AN is equals to 256. So actually we do not have N over here. Okay, so but you know that AN is equals to A R N minus 1. Okay, so this we know. So you can actually get it as your 256 is equals to 4 R N minus 1. Okay, so this will be R N minus 1 is equals to 256 by 2. Okay, so this actually gives you 1, 1, 2, 8, R N minus 1. Now, if you see this, 128, okay, so 128, is going to be some kind of, multiple of your 2 itself. Okay, so you can actually find what is the how what raised to 2 is going to be this. So your R is going to be actually 128 n minus 1. Okay, so this actually is going to give you, or we want not writing this form. First, let us find what is actually 128. What is the uh, power of 2, which will give you R and minus 1. Actually, that is going to be 2 raised to, I think, 7. Okay. Yeah, so 2 raised to 7 is going to give you your, 128. So that means your n minus 1 is equals to 7, and therefore your n is equals to going to be, your n is 6. Oh, sorry, your n is 8. Okay, so your n is 8. So what do you mean by n is 8? So your first number you have as 2, and your eighth term is actually 256. So between the eighth term and the first term, you will actually find how many. So if your n plus 2, okay, suppose this is a different n, or maybe not right n, you can write, yeah, 256 is your I plus term. Okay. So this is your I plus 2 term, and because this is your I plus say 0 term, so this will be you have G1, G2, and I plus 2 is actually your eighth term. Okay. So this is actually going to be 6. So we have to find the 6 in between terms. So G3, G4, G5, and G6. Okay. So then you will have the total number at 8. Okay. So we will find G1, G2, G3, G4, G5, G6. So how do we find that? Your G1 is actually your A2, and A2 will be given as AR. Okay. So we actually found our N. Okay. So that is N is equals to 8. Now we find your R also accordingly. Okay. So what is your R? Now we have 256 is equals to 2 into you have R raised to 7. Okay. Sorry. And then you will have R raised to 7 is equals to again 256 by 2. So that is 128. Okay. So your R actually turns out to be 2 itself. Okay. So therefore, you will have 2 into 2. So that means 4. G2 is going to be 8C. So this is going to be your AR squared. Okay. So that is 4 into 2. That is 8. And G3 is going to be A4. So that is going to be AR cube. So 8 into 2 again. So that is 16. J4, you have A5. You have AR4. So 16 into 2, that is 32. G5, A6. That is going to be AR raised to 5. So 32 into 2, that is 64. And you have the last term. So that is you have A7. That is AR raised to 6. And that is 64 into 2 is 128. So therefore, the resultant GP is 2, 4, 8, 10, 32, 64, 128, and 256. Okay, let's find the GM for this. Okay, so as for the formula that we have, you will need 2 into 4 into 8 into 16 into 32 into 64 into 128 into 256 and the eighth root of the product of all these terms. Okay, so we'll quickly calculate the product of all these terms so that we will get as 2 into 4 into 4 into 8 into 16 to 32 into 64 into 128 into 256. Okay, and we'll need to find the eighth root of this. Okay, so that is actually 22.627. Okay, you can round it up out to 22.63. Okay, you see, this is not exactly, in any of the middle part. It is actually going to fall between 16 and 32. Okay, so, but if you have, okay, so this was the entire GP. Okay, but if you only had to find GM of the two end members only. Okay, so the end members only. So that is 2 and 256. Let's see if that also actually, if the value comes out to be same. So GM of is square root, GM is equals to square root of 2 into 256. This 2 actually comes out to be 22.627. 22. So you can see that, to find the GM of, say, GP, uh, you do not need the entire sequence of the, you do not need the entire sequence. You can find the geometric mean by using just the two end members of the geometric progression also. Okay, so you can see that the values are the same. And you can see that the central tendency of the geometric, progression actually lies between 16 and 32. So it lies between your A4 and A5. Okay. So this is the use of, geometric mean. It does not give you like the exact mid of the sequence maybe, but it will show you where the, center or the tendency of it of the data is, the tendency of the data to get centered, okay, at which value is going to be given to you by geometric mean. So today we will stop here, and in the next class we will see a few more examples, related to geometric progression, geometric series, geometric way. Okay, and later on we'll continue with the relationship between arithmetic mean and sum. Okay, so thank you for attending.